Hello everyone and welcome to our session on the Qualitative Risk Analysis Process for construction projects, brought to you by Roa Handisia. In construction projects, we do not face only technical challenges. We operate in an environment full of uncertainty, changing requirements, supply delays, coordination issues, and constant pressure on time and cost. Qualitative risk analysis represents the first practical tool that allows us to understand these uncertainties and prioritize them, instead of dealing with risks randomly or through late reactions. Throughout this lecture, we will move from theory to practice, using realistic examples from real construction projects. The objective of this lecture is not to memorize terminology, but to build analytical capability. By the end of this lecture, you will have a clear understanding of the role of qualitative risk analysis and where it fits within the project risk management framework. Furthermore, you will be able to identify key inputs and apply probability and impact scales to effectively prioritize risks that affect project cost, time, and quality. So, what is qualitative risk analysis? It is a structured process designed to determine which risks require immediate action and which can simply be monitored. At this stage, we are not calculating precise numerical values or complex statistics. Instead, we focus on prioritization using professional judgment and systematic methods. This is achieved by assessing the likelihood of occurrence and the potential impact on project objectives. We also consider factors such as urgency, detectability, and strategic importance. Through this approach, a long list of risks is filtered into a focused set of critical threats. Ultimately, the purpose of this analysis is to concentrate limited resources on the risks that truly matter. In construction projects, where not all risks deserve the same level of attention, this process allows managers to prioritize high-impact threats rather than reacting to every minor uncertainty. Within the risk management framework, qualitative risk analysis is the first evaluation process following risk identification. While it begins immediately after risks are identified, it is not a one-time event. This process is performed continuously throughout the project lifecycle to account for new and evolving threats. Once we identify our risks, we must determine which ones matter most. The outcome is a prioritized risk register that forms the essential foundation for risk response planning. Without this clear prioritization, our risk responses would be inefficient and difficult to justify. Ultimately, this allows us to distinguish between critical threats requiring immediate action and minor risks that can simply be monitored over time. Effective qualitative risk analysis requires a reliable set of inputs to ensure that risks are assessed consistently and in alignment with the project's objectives. The first key input is the project management plan, which provides the overall framework for conducting risk analysis in a structured and systematic way. Within this plan, the risk management plan is the most critical component, as it defines how risks are identified, assessed, and prioritized. Key supporting elements include defined roles and responsibilities, a clear budget for risk management, and the risk breakdown structure, which categorizes risks to ensure comprehensive coverage. Standard definitions of probability and impact, along with the probability impact matrix, support objective risk prioritization, while stakeholder risk thresholds define acceptable levels of risk and escalation criteria. The second group of inputs consists of project documents. The assumption log highlights uncertainties that may turn into risks, the risk register provides the list of identified risks for evaluation, and the stakeholder register helps understand stakeholder influence and risk perceptions. Finally, enterprise environmental factors and organizational process assets provide the organizational and external context, including regulations, culture, historical data, and lessons learned. Together, these inputs create a solid foundation for systematic and effective qualitative risk analysis. Qualitative risk analysis relies heavily on expert judgment, utilizing the insights of both internal team members and external specialists. Data is gathered through structured techniques such as interviews, workshops, and consensus methods to capture these subjective assessments. To ensure accuracy and reduce individual bias, it is vital to involve multiple perspectives in this evaluation process. The most critical tool in this process is the probability and impact matrix. This matrix transforms individual assessments into a clear, visual representation of risk exposure by mapping likelihood against consequence. For this to be effective, all participants must share a common understanding of the probability and impact scales being used. Finally, documenting the reasoning behind each risk ranking improves transparency and provides a reliable foundation for future reviews. The Perform Qualitative Risk Analysis process produces several outputs that guide decision-making and risk response planning. Risk register updated with qualitative assessments for each risk, including probability and impact ratings, overall risk priority, and identification of risks needing immediate attention. This helps the team focus on high-priority risks rather than all risks equally. Risk report summarizes the project's overall risk exposure, highlighting significant risks, trends, and areas of concentration across objectives like cost, time, quality, and safety. It aids senior management in strategic decision-making and resource allocation. Assumptions log reviewed and updated as some assumptions may increase uncertainty. Assumptions are revised or flagged for monitoring to capture hidden risks. Issue log updated if a risk has already occurred. Such risks are treated as issues, triggering corrective action rather than risk response planning. These outputs provide a structured, prioritized, and documented view of project risk, forming a strong foundation for planning risk responses. To ensure qualitative risk analysis is effective and consistent, several best practices should be followed. First, it is essential to define clear probability and impact rating scales. These scales must be agreed upon by the project team in advance and documented in the risk management plan. Clear definitions reduce subjectivity and ensure that all participants interpret terms such as high probability or major impact in the same way. Second, the process should engage a diverse team of experts. Risk assessment is strongest when it includes perspectives from design, construction, procurement, health and safety, and project control. This diversity helps uncover risks that may be overlooked by a single discipline or individual expert. For example, a designer may spot structural risks, while a contractor identifies supply chain bottlenecks. Third, qualitative risk analysis should be conducted through structured risk workshops or formal meetings. These sessions encourage open discussion, challenge assumptions, and promote shared understanding. Structured workshops are particularly effective in complex construction projects where risks are interconnected. Next, risks should be prioritized visually using a probability impact matrix. Visual tools make it easier to communicate risk severity to stakeholders and decision-makers. They also help quickly distinguish between risks that require immediate response planning and those that only require monitoring. Another critical practice is to assign risk owners for accountability. Each high-priority risk should have a named individual responsible for monitoring the risk and implementing response actions. Without clear ownership, risks are often ignored or addressed too late. Finally, qualitative risk analysis must be reviewed and updated regularly throughout the project lifecycle. As project conditions change, new risks emerge and existing risks evolve. Regular reviews ensure that risk priorities remain relevant and that the risk register continues to support informed decision-making. Together, these practices ensure that qualitative risk analysis is not a one-time exercise, but a living process that actively supports project success. Let's move from theory to practice. Our case study examines risk management practices from a public school construction project in Gothenburg, Sweden. This real-world example will demonstrate how qualitative analysis is applied to complex infrastructure projects. This case study focuses on a public school construction project in Gothenburg, Sweden. The project was designed to achieve high-quality standards while operating under strict time and cost constraints. The study's objectives are threefold: to evaluate the risk management practices used, to assess how risks were identified, analyzed, and managed, and to recommend specific improvements for future projects. The study was based on a detailed review of project documents, interviews with the project team, and a comparison between the actual risk management practices and the guidelines outlined in PMBOK. This allowed a clear understanding of how risks were currently being identified, assessed, and monitored within the project. The findings revealed several significant challenges. First, there was no structured process for identifying risks, which meant potential threats could easily be overlooked. Documentation of risks was poor, making it difficult to track or follow up on issues over time. Communication with stakeholders was limited, reducing the team's ability to capture diverse perspectives on potential risks. Additionally, formal tools such as risk matrices, checklists, and other analytical aids were not utilized, and time and budget constraints further hindered proper risk management. Overall, the study highlighted that risks were being managed informally, without the use of structured analytical tools, which can result in high-priority risks being missed or inadequately addressed. This emphasizes the importance of adopting formal risk management processes to improve decision-making and project outcomes. Applying a structured qualitative risk analysis approach leads to several tangible benefits in construction projects. First, there is increased risk awareness. Project teams become more alert to emerging threats because risks are discussed openly and assessed systematically. This heightened awareness allows for earlier recognition of potential issues and enables proactive monitoring rather than reactive problem-solving. Second, qualitative risk analysis results in improved collaboration. When risks are clearly identified, documented, and prioritized, communication among stakeholders becomes more focused and transparent. This shared understanding reduces misunderstandings, minimizes conflicts, and supports smoother coordination across different project disciplines. Third, there is better decision-making. By prioritizing risks based on their probability and impact, project managers can make faster and more informed decisions. Evidence-based risk prioritization improves schedule reliability, supports efficient allocation of resources, and strengthens overall project control. Another key benefit of applying qualitative risk analysis is early prevention of issues. By proactively identifying risks at an early stage, project teams are able to address potential problems before they escalate into serious disruptions. This early intervention minimizes schedule delays, reduces rework, and limits unexpected cost impacts on the project. In addition, qualitative risk analysis supports the identification of system gaps. The structured assessment process often reveals weaknesses in existing procedures, unclear roles, or gaps in responsibilities. Recognizing these shortcomings allows the organization to implement targeted improvements, ultimately strengthening the overall project management system and reducing the likelihood of similar issues recurring in future projects. Together, these outcomes reinforce the value of qualitative risk analysis as both a preventive tool and a driver of continuous improvement in construction project management. Risk probability assessment is a fundamental element of qualitative risk analysis. It focuses on estimating how likely a risk event is to occur during the project lifecycle. In construction projects, probabilities are rarely known with precision. Instead, they are estimated using expert judgment, historical data from similar projects, and collective experience from the project team. To ensure consistency and minimize subjectivity, probability is evaluated using a clearly defined rating scale. This scale typically ranges from very low to very high, with associated numerical values such as 0.1, 0.3, 0.5, 0.7, and 0.9. These numerical values are not exact statistical probabilities. Rather, they serve as relative indicators, allowing different risks to be compared using a common and transparent reference. For instance, a risk rated as very low has a small chance of occurring, while a very high risk is considered highly likely unless preventive measures are taken. Assigning probability values in this structured way supports semi-quantitative risk scoring. This enables probability ratings to be combined later with impact values, forming the basis for risk prioritization and informed decision-making. By using a standardized probability scale, project teams improve alignment, enhance communication, and strengthen the overall reliability of the qualitative risk analysis process. Risk impact assessment focuses on evaluating the potential effect of a risk if it occurs. Impact refers to how a risk may affect one or more project objectives, particularly time, cost, and quality. The assessment uses standardized impact levels ranging from very low to very high, supported by numerical scales. These scales ensure consistency and objectivity when evaluating different risks across the project. For cost, the impact may range from insignificant increases to severe overruns exceeding 40%. For time, The effect can vary from minimal delays to schedule overruns greater than 20%. For quality, impact levels progress from barely noticeable degradation to outcomes where the final deliverable becomes effectively unusable. Color coding is used to represent increasing severity, allowing risks with the greatest potential consequences to be identified quickly. Impact thresholds reflect the organization's risk tolerance, and higher impact levels signal the need for priority attention and response planning. Through this structured approach, project teams can compare risks systematically and focus their efforts on managing the most critical threats to project objectives. The risk matrix is a key tool used to prioritize risks by combining probability and impact into a single risk score. Probability represents the likelihood that a risk will occur, ranging from very low to very high values along the horizontal axis. Impact represents the severity of the consequences if the risk occurs, increasing along the vertical axis. Each cell in the matrix shows a risk score, calculated by multiplying probability by impact. Higher values indicate risks that have a greater influence on project objectives. Color coding is used to support quick interpretation. Green areas represent low-level risks that may be accepted or monitored. Yellow and orange areas indicate moderate risks that require attention and possible mitigation. Red areas represent high and very high risks that demand immediate response planning and management action. This structured visual approach allows project teams to compare risks consistently, focus resources on the most critical threats and opportunities, and align decision-making with the organization's risk tolerance. By using the risk matrix, qualitative assessments become more transparent, objective, and easier to communicate across all project stakeholders. The risk score is calculated by multiplying probability by impact. For example, a probability value of 0.7 combined with a high impact value of 0.40 results in a risk score of 0.28. This numerical outcome allows risks to be compared objectively and consistently. Based on the calculated score, risks are prioritized into categories. High risks require immediate response planning, medium risks call for mitigation and ongoing monitoring, and low risks are placed on a watch list for periodic review. This structured approach supports objective prioritization, improves response planning, and ensures that attention and resources are directed toward the risks that most significantly influence project objectives. This example demonstrates how qualitative risk analysis evaluates the same risk across different project objectives by combining probability and impact. Each identified risk is assessed against cost, time, and quality, rather than being treated as a single, uniform issue. A common probability value is assigned based on how likely the risk is to occur, while the impact level varies depending on which project objective is affected. For example, delays in the construction schedule may have a moderate probability, but their impact on time can be significantly higher than their impact on cost or quality. Similarly, a miscalculation may have limited consequences for quality but a severe impact on cost or schedule. The resulting risk scores, calculated using the probability impact matrix, highlight these differences clearly through color coding and numerical values. This approach helps project teams understand that a single risk can influence project objectives in different ways, enabling more precise prioritization and targeted response strategies. By analyzing risks at the objective level, decision-makers can focus mitigation efforts where the potential impact is greatest, improving overall project control and performance. The case study highlights several important lessons learned, beginning with the importance of adopting a structured methodology for risk management. Effective qualitative risk analysis cannot rely on ad hoc judgments or informal discussions. Instead, it must follow a clear, systematic, and repeatable process that ensures risks are identified, assessed, and prioritized in a consistent manner. When risk management lacks structure, critical threats may be overlooked, assessments may vary between team members, and decisions may become subjective and unreliable. A formal approach provides clarity, transparency, and defensible reasoning behind risk-related decisions. Another important lesson is recognizing the risk register as a living document, rather than a one-time deliverable. Risks do not remain static throughout the project lifecycle. New risks can emerge, existing risks can escalate or diminish, and assumptions may change as the project progresses. Continuously updating the risk register ensures that it reflects the current project reality and keeps risk information relevant for decision-making. This allows the project team to maintain real-time visibility of risk exposure, supports proactive monitoring, and strengthens the link between qualitative risk analysis and effective risk response planning. Strong stakeholder engagement is essential for high-quality risk identification and assessment. Involving clients, contractors, designers, and project managers brings multiple perspectives into the process. This diversity improves the completeness of identified risks, strengthens communication, and promotes shared ownership of risk management outcomes. The case study also demonstrates the value of using formal tools and techniques. Structured methods such as checklists, risk breakdown structures, probability impact matrices, and standardized documentation significantly enhance accuracy and transparency. These tools reduce subjectivity, support consistent evaluations, and strengthen accountability across the project team. Regular risk meetings play a vital role in maintaining an effective risk management process. Consistent and scheduled discussions provide opportunities to review existing risks, identify new ones, and validate assumptions. These meetings help surface issues early, before they escalate into major problems, and keep the team aligned on priorities throughout the project. At the same time, successful risk analysis requires a balanced approach between professional experience and data. Expert judgment is invaluable in construction projects, where uncertainty is common. However, judgment alone is not sufficient. It must be supported by documented data, structured analysis, and validated information to ensure credible and defensible decisions. Effective qualitative risk analysis directly improves project predictability. When risks are identified early and prioritized correctly, projects experience fewer delays, reduced cost overruns, and less rework. As a result, outcomes become more stable across scope, schedule, and budget, supporting overall project performance. Clear roles and responsibilities are equally important. Assigning a specific risk owner to each identified risk ensures continuous follow-up, monitoring, and timely action. Clear ownership prevents accountability gaps and ensures that risks are actively managed rather than overlooked as the project progresses. Proactive risk management is a defining characteristic of successful projects. Early identification allows teams to take early action, increasing control and reducing the likelihood of crises. This proactive mindset minimizes the need for costly reactive measures and supports smoother project execution. Finally, the case study emphasizes organizational learning. Documented processes, structured analyses, and recorded lessons learned create a valuable knowledge base. This knowledge strengthens future projects, improves consistency, and enhances the organization's overall maturity in risk management practices. Now, take a moment to reflect on a construction project you have studied, worked on, or closely observed. Consider how risks were assessed in that project. Was the assessment driven by a single expert's opinion, or was it the result of a structured, collaborative workshop involving multiple stakeholders? Think about the tools that were used. Did the team rely on a formal probability impact matrix, or were decisions based largely on experience and gut feeling? Also consider whether risks were evaluated separately for safety, budget, and schedule, or treated as a single general concern. Finally, ask yourself how a systematic scoring approach might have changed the project's top 5 risks. Would different risks have received higher priority? Would management attention and resources have been allocated more effectively? Now, apply this thinking to the quiz question. Which of the following best describes the purpose of qualitative risk analysis? A. To calculate exact contingency costs? B. To assign risk owners and implement responses? C. To prioritize identified risks based on their probability and impact? D. To eliminate all high-risk events? E. To monitor risks during project execution? The correct answer is C. To prioritize identified risks based on probability and impact. Qualitative risk analysis does not calculate exact costs, implement responses, eliminate risks, or monitor execution. Its primary purpose is to evaluate and rank identified risks using qualitative measures, most commonly probability and impact, so that management attention and response planning can focus on the most significant risks. To conclude, qualitative risk analysis plays a critical role in prioritizing identified project risks by evaluating their probability of occurrence and potential impact. This prioritization provides a structured foundation for effective risk response planning and aligns with internationally recognized PMBOK standards. The process relies heavily on probability and impact matrices, supported by expert judgment, to classify risks into high, medium, and low priority levels. This visual and structured approach allows project teams to focus their attention and resources on the risks that matter most. Assessment reliability is further strengthened through risk data quality evaluations, ensuring that assumptions, data sources, and scoring criteria are consistent and credible. In addition, factors such as risk urgency and specific risk categories are considered to enhance the depth of analysis. Finally, while construction projects often rely on informal or experience-based risk management, this case study demonstrates that applying a structured qualitative analysis leads to more actionable risk registers, clearer priorities, and significantly improved decision-making outcomes. The key references supporting this presentation are as follows. First, the Project Management Institute 2017 published a guide to the project management body of knowledge, commonly known as the PMBOK Guide 6th edition. This guide provides the globally recognized standard framework for effective project and risk management practices. Second, a real-world construction case study by Gajuska and Ropel from Chalmers University of Technology was used to demonstrate how qualitative risk analysis is applied in practice and to highlight valuable lessons learned from an actual project environment. Thank you for watching and engaging in this session. Qualitative risk analysis is more than a formal process. It is a structured mindset that helps teams assess uncertainty, prioritize risks, and make informed decisions based on probability and impact. By applying this approach early and consistently, construction projects become safer, more predictable, and better prepared to handle uncertainty. If you found this lecture valuable, please like the video and subscribe for more content on construction risk management and project delivery.